Hello students, myself Dr. Mansoor Maulavi, Department of Chemistry, PDA's Professor Ramkrishna More, College Akodi. Today we are going to look at conformation isomerism, conformations of n-butane. In the previous lecture, we have seen about the basic concept of conformation isomerism and conformations of ethane. Now, today we are looking the conformations of n-butane. N-butane molecule can be presented by the formula C4H10. So its structure is CH3, CH2, CH2 and the CH3. When we rotate carbon-carbon single bond, that is the C2 and the C3 of n-butane by about 60° dihedral angle, then we observe the four types of conformation. These four conformations are fully eclipsed or seen conformation, Gauch conformation, partially eclipsed conformation, and staggered or anti-conformation. One by one, we will cover that conformation. First conformation, the fully eclipsed or seen conformation. It is a sawhorse notation of fully eclipsed or seen conformation of n-butane. Here we observe that two non-bonded methyl groups are eclipsing to each other. This can be best viewed in the Newman projection formula, in which two non-bonded methyl groups, two non-bonded hydrogen, are eclipsing to each other. This fully eclipsed conformation of n-butane observed at 0° dihedral angle because of the electronic and the steric interaction of the methyl group, hydrogen. The potential energy of Newman projection formula, the potential energy of fully eclipsed conformation of the n-butane is 4.5 to 5.0 calorie per mole. So we can define the fully eclipsed or seen conformation of n-butane as conformation of n-butane in which two non-bonded methyl groups and the non-bonded hydrogens are eclipsing to each other is known as fully eclipsed or seen conformation. We will look that conformation in this formula. At 0° angle, we observed this fully eclipsed conformation. This is the Newman projection formula for the fully eclipsed conformation. These two methyl groups are eclipsing to each other, and these two hydrogens are eclipsing to each other. This is the Newman projection formula for eclipse conformation of n-butane. Here, the interaction between these two methyl groups is very clear. So we observed that eclipse conformation of n-butane observed at 0° dihedral angle. The second conformation of n-butane is Gauch conformation. When we rotate the carbon-carbon single bond of n-butane by about 60°, then we observe the Gauch conformation. Here, these two methyl groups are slightly going away from each other at dihedral 60°. This is anti-clockwise rotation. This is clockwise rotation. In Newman projection, we observe two methyls are gauged to each other at dihedral angle 60°. When we make one full rotation, then this Gauch conformation of n-butane is observed at 60° and 300°. We can say this, it has plus 60°. This is minus 60°. Since all the groups are going from each other, the energy of Gauch conformation decreases, and this potential is 0.9 kilocalorie per mole. So we can define the Gauch conformation of an ethane n-butane as conformation of n-butane in which two non-bonded methyl groups are gauged to each other is known as the Gauch conformation. So in molecular modeling, We are rotating this carbon-carbon single bond of n-butane by about 60 degree. So this is the Gauch conformation observed at this is the anti-clockwise rotation. Then this is the clockwise rotation. So we can say the Gauch conformation is observed at 60 degree and 300 degree or minus 60 degree. Third conformation is the partially eclipsed conformation. Further rotation of carbon-carbon single bond of n-butane by 120 degree. We observed the methyl hydrogen interaction alternately. This is observed at 240 degree and the 120 degree. It is clockwise rotation, it is anti-clockwise rotation. Both images are superimposable images of each other. So we can define that conformation of n-butane in which two methyl groups are eclipsing with non-bonded hydrogen is known as partially eclipsed conformation. This partially eclipsed conformation is observed at 120 degree and the 240 degree. The potential energy of this conformation is 3.5 kilocalorie per mole. So we are rotating the carbon-carbon single bond by about 120 degree. So we observe this hydrogen and these carbons are eclipsing. This methyl and this hydrogen are eclipsing, and this hydrogen are eclipsing to each other. So the energy of that conformation is 3 kilocalorie per mole. So it is plus 120 degree. We have the minus 120 degree, that is the 240 degree also. So at both we observe the partially eclipsed conformation of n-butane. So from 0 degree we are going to 60 degree Gauch conformation, and at 120 degree we observe the partially eclipsed conformation of n-butane. The fourth conformation of n-butane is staggered or anti-conformation. This is the Newman projection formula. This formula shows that two methyl groups, non-bonded methyl groups, are at anti to each other or at 180 degree to each other. So this conformation of n-butane is observed at 180 degree. All the methyl groups are going far much away from each other. Hydrogen is also going far much away each other. So potential energy of that conformation is 0 calorie per mole. So the conformation of n-butane in which two non-bonded methyl group and hydrogens are anti to each other is known as the staggered or anti-conformation of n-butane. So further we are rotating the carbon-carbon single bond by about 180 degree. Then we observe that these two methyl groups are opposite to each other. These two methyl groups are opposite to each other. So the energy of that conformation is the 0 kilocalorie per mole. So this is the n-butane. So we will revise all the conformation. At 0 degree, we observe the fully eclipsed or seen conformation. At 60 degree, we observe the Gauch conformation. At 300 degree, we observe the Gauch conformation. At 120 degree, we observe the partial eclipse conformation. At 240 degree dihedral angle, we observe the partial eclipse conformation, and at 180 degree, we observe the staggered conformation of n-butane. So n-butane shows the four type of conformation: the fully eclipse conformation or seen conformation, Gauch conformation, partially eclipse conformation, and last is the staggered or the anti-conformation. So we are going to compare the energy and the stability of conformation. This is the energy profile diagram for all the conformation of n-butane. We are starting from the 0 degree dihedral angle. At 0 degree dihedral angle, we observe the fully eclipse or the seen conformation. It contains the methyl non-bonded interaction, steric interaction, and the electronic interaction. In this conformation, we observe the maximum interaction. So energy of that fully eclipse or seen conformation is 5 kilocalorie per mole. Further rotation of carbon-carbon single bond by about 60 degree gives the Gauch conformation. Energy of the conformation decreases. The energy of Gauch conformation is 0.9 kilocalorie per mole. Further rotation of carbon-carbon single bond by about 120 degree, we observe the partial eclipse conformation. The energy of system increases. At 120 dihedral angle, we observe the partial eclipse conformation. The energy of partial eclipse conformation of n-butane is 3.5 kilocalorie per mole. At 180 degree, we observe the staggered conformation, and it is the most stable conformation. In this conformation, all the steric interaction and the electronic interaction are absent because all the non-bonded groups are going from each other. So staggered conformation is the most stable conformation in the conformation of n-butane. So accordingly, if we go on further rotating the carbon-carbon single bond, it is converted into partial eclipse conformation, Gauch conformation at 300 degree, and at 360 degree we observe the fully eclipse conformation. So energy of all the conformations of n-butane is fully eclipse conformation 5 kilocalorie per mole, Gauch conformation 0.9 kilocalorie per mole, partial eclipse conformation 3.5 kilocalorie per mole, and the staggered or anti-conformation is 0 kilocalorie per mole. So when we compare the stability of all the conformation, then we observe that staggered or anti-conformation of n-butane is stable over the Gauch conformation, more stable over partial eclipse conformation, is more stable over the fully eclipse conformation. So we can say that the n-butane molecule is observed in the staggered conformation. In this, because the staggered conformation, the energy potential energy of the conformation is the minimum than other conformation. Thank you.